Now it's time to talk about something known as Web Vitals, and in particular, Core Web Vitals. So what's the deal with Web Vitals? It's an effort led by the Google Chrome team, but it's open to anyone, to define vitals, like what are the most important metrics that we want to focus on as web developers for web performance, and they are calculated over the 75th percentile over mobile and web. It doesn't matter, but actually the idea is to get real user metrics, and based on real user metrics, define a set of rules that might change with time. In fact, they have been changed a couple of times for us to create better websites. So the idea was actually to define like a common goal for web performance, because if not, it's not clear how fast it's fast. And today, Core Web Vitals is actually including 3 metrics. One that we have already covered, but actually 2. We have already covered 2 of those. Largest contentful paint, that is measuring loading. First input delay, that is measuring interactivity, how interactive your website feels. I'm not saying that this is what will happen in the future. I will explain that in a second. And then CLS, cumulative layout shift, that detects visual stability. Actually, when you are loading a website and then the website moves around, the elements are moving because an image appears, and then you've seen this on typically on newspapers. You are reading the article, and then the article shifts down because a large ad appeared at the top. Well, that's a layout shift, and it's bad for performance. So first input delay is the only one that we are not actually using it too much, and it's probably going to be replaced by another one. So after a couple of years of testing it, we ended up saying, well, you know what? It doesn't feel like the best metric, so it's probably going to be replaced by another one. So, but again, even if you are setting large contentful paint as something important, again, the largest contentful paint, you will see an example in a second. So let me go directly there. It checks initial load. So it's like replacing the idea of how fast your website is loading, is at which point the most important part of the content appears on the screen. And because it has to do with the screen, it will be different on different viewport sizes. So if you're using responsive design, based on the width of your screen, the design of the home page is different, or the landing page is different. So it might be different on mobile, on desktop, on tablets, because the website is different. Okay. First input delay, then it checks interactivity, so at which moment you are releasing the thread enough to, like, for example, interact with the content, and the visual stability, that we don't want the content to shift around while the page loads. So, for example, we can actually try to see here different metrics in which moments they are happening. Okay. For example, typically when you see that your content goes to white, is time to first byte. How do you know that? For example, you are on a website, google.com, okay? And then you search for the best library for web developers, and Frontend Masters appears. And you click on the link. When you click on the link, it doesn't go to white immediately, at least not now. It was in the 90s. You're still at Google, okay, for a couple of milliseconds or seconds, and after a while, you see white. When you see white is when time to first byte has fire. So it depends on the browser, actually, but simplifying, let's say that that's the moment. Then you see, in this case, a background. That's that gray background. That's first paint. So the browser paints something. Is it useful? No. So it's just a gradient. Okay. So it's not useful for our brain. Remember, we're doing this for the user. And our brain says, yeah, something is there, but it's like, I don't feel the content is ready. So I don't feel that the website was loaded. Then something appeared. Okay. In this case, the search box. So this is known as content. Is it the most important content? Probably not, but it's still something that my brain parses. So we are talking about brain parsing right now. It's there, but it's not really, really important. First, now if you look at the end here, at the end, we see which one can be our largest contentful pane. That sometimes we have candidates because we don't know which one is the largest, but probably it has to do with the results that we are looking for. So that's what we're expecting. Okay, I will show you another example to see this. But actually, the browser will actually do this for us. It will say, okay, this is the largest contentful pane. I will explain how to see that in action in a second. But here you have an example of first contentful pane that we haven't mentioned a lot because it's not really so important, and largest contentful pane, that is the one that is important. Contentful is actually an element, a box on the page that has content. It can be text or it can be an image. And while the page loads, the browser calculates different candidates for largest contentful pane. For example, for a while, it was this one, that title. But at the end, it was actually the image. So this is largest contentful pane. And when that image is rendered, it's fire. Again, what fire means? Nothing. It's for analytics only. But it fires in our brain. That's the idea. The idea of largest contentful pane is firing something in our brain, user's brain, saying, oh, the most important content is there on the screen, so I can start reading, I can start parsing this. Yes?
Is it based on geometry because the image is larger than the...
Okay. It's geometry. It's larger. It's about geometry of the element on the screen. In the case of, I mean, it's about rendering, not about CSS. So I know if you have an image with a lot of padding, it's not taking the padding in consideration. It's about the content itself, right? Not about the HTML element and the CSS inside. It's not the box of HTML. It's what you see on the screen, actually. Okay? Yeah.
If you put like a skeleton, like using suspense or like a loading sort of thing like that, I would assume that would like keep people engaged. Is there like a percentage for that is effective for keeping those people engaged to stay on that while it's loading?
Well, let me answer first with something. Never assume.
Okay.
Test it. And so again, don't trust anyone. That's first rule. Second rule, don't assume. In fact, there is it's old at this point. I can't even Google that special if it's still there. Let me see if it's there. So Luke Wroblewski, that's the name. Luke W. It was a blog post from Google about that, loading a spinner. Like, let me see if I can find it. Avoid the spinner. That's the one I was talking about. Look at it's from 10 years ago. And he was saying, avoid the spinner. That was you were suggesting. Okay. So he was saying, don't do this. Why? Because if you do that, you are like creating a big sign in your website saying that you're slow. So yeah, but that's the Gmail case actually. Remember when you saw the Gmail? What happens when you do that is the speed index goes wrong. You get the worst speed index because you see just the loading spinner for a lot of time and then everything is rendered. So sometimes you don't have any other option. I mean, you're loading a Netflix movie and the movie is not coming. Well, you have to put loading. Okay, but for standard web apps and website-based or content-based websites, it's a good idea to avoid the spinner. And again, for that you need to just test this with your user. You can do A/B testing. And in this case, the idea is to start rendering parts of the content or placeholders. And you can see this a lot in social networks, TikTok, Facebook, Instagram. If it's taking time, you actually get to see these kind of placeholders that it feels, sometimes it's an animation, it feels like we are typing. We have some little guys inside the computer typing. So it's like an effect that it's not really a loading spinner, but it's kind of giving you the effect, it's tricking your brain to get you there. So we need to remember, why are we doing performance? We are doing performance at the end because we are losing money, okay? Why are we losing money? Because our users are unhappy about the performance. That's not, I mean, users are not sometimes conscious about that, okay? So it's not like, oh, this website is slow, let's get out of here. You click on a link, it doesn't work, you don't feel it's what you are looking for, you get out. So that's the moment that you are losing the user. So because we are losing the user, we care a lot about perception, users' perception. So we are doing web performance because of users' perception, that leads to better conversion. Okay? So that's why we're doing this. So that's why tricking the user sometimes makes a better result. And let me give you a short story. I will probably explain it quickly without all the details, but it has nothing to do with the web, but it has to do with tricking users' mind. So that is typically something that is part of a lot of books around web performance. So there was an airport, I'm not sure, I don't remember if it was Boston or Chicago. Boston or Chicago, I don't remember right now. They did a survey on the travelers going through the airport, about the airport, and everyone was complaining that they were waiting a lot of time for the luggage to appear. When they tried to see how to improve that, they realized there were no way to do that. Okay, so they were, in terms of performance, they couldn't improve that. So the answer to that was to actually put the gates farther away. So then users have to walk more to get to the belts and get the luggage, and then they ask the users if they improve that, and they were saying yes, you improve because you were waiting less. It's a trick, it's a mind trick. Okay, so now you walk more, you wait less, and you feel that now you had a better performance. Okay, and something similar is what we're doing here sometimes. You are tricking the user so the user thinks that that's ready, that's loading, or it's there. And if you put the spinner, the loading spinner, you are not tricking the mind, you are saying, I'm slow, please wait. Okay? It's like on the phone when you say, please wait, and you hear the music, it's like, and your first reaction is negative to that. Okay? So that's why, but again, don't trust Luke, try it. Okay? So, and it depends on the case, it depends on what you're doing, what's your project, but just remember that we are doing this for the user. Okay, so the answer will be how the user will perceive this.
So you maybe be more likely to get better results if it's not a spinner necessarily, but an engaging animation of some sort.
Something, yeah. Something that the trick is that it feels like it's loading, it's generating, it's coming, it's there.
They're using their time well.
Yeah. But it's something that you can try, so you can test. You can do A/B testing, and over your users that might be different to other users from other websites. Maybe your community is different, so try it. Okay, measure it and try it. Yeah.
Yeah. Facebook uses that kind of pulsing content outline thing. Have you seen that?
Yeah, like a placeholder. I don't know if they have something. Well, they don't have that one here, but yeah, it's like. You feel like a paragraph of text, but it's not really text.
Oh, yeah.
That's kind of, an animation it's really, it's not a small animation. It's not really huge, but.
And then I've seen those, they take an image and they make like a placeholder SVG that's kind of the outline of the image. They show that first and then they show the image.
Yeah, there are, I remember one trick that was to take images. So if you have an image, I mean for a newspaper, I'm not sure if I have like one, let's say this one, and for that image, but actually after a while, newspapers stopped doing that because they realized that they had another issue, but they were taking the image server side and resizing the image to really, really small, such as 16 by 16 pixels, really, really small. They were converting that into a base64, an inline image, and then they were inlining in the IMG tag just a very, very compressed version of that image. So then when you load the page, initially you see a very, very low resolution of the image. It's more like a couple of colors, like large pixels with colors. And then after a while you replace that with a real image, and that was a trick, okay, for users' perception that that image was loading, even if it wasn't true. You weren't loading the image. Anyway, try it. So try different techniques, test them on the real world, and see which works best. There are more metrics in Web Vitals. For example, there is one that today is experimental. That's the one that I think is going to replace the interactivity part. It's interaction to next paint. This metric will try to measure responsiveness based on a more complex algorithm, but now Chrome is supporting it. From Chrome, I think it's 108, is supporting interaction to next paint. So have in mind that Web Vitals, this community effort to define metrics, will change over time. So every once in a while, they sit down and see, okay, let's see the metrics that we have defined. If they're still good or not, let's gather real user metrics and see if that's the right metric, or maybe we have to change that. Okay? And I know that some people will say, hey, my website is fast, because we don't have like a clear definition on what's fast. Okay? So how fast is fast? So we have to define performance budgets. And Web Vitals already set some performance budget that you can follow or not, or you can define your own budget. I will talk about budget a lot. Okay? You will see why. These are the current budgets for the 3 core Web Vitals defined. If you are under green, you're good. If you are under yellow, needs improvement. If you are over the yellow, you're pretty bad. That's kind of the idea. So LCP, largest contentful paint, should appear in the page within 2.5 seconds for at least 75% of your users in the real world. That's kind of the idea. Not for everyone, because you don't know if the user is in 2G in the middle of the Alps, and yeah, well, you can't do anything about that. So that's why it's for 75% of your users, and you can gather that with real user metrics. You have to render the largest contentful paint, the image, the title, within 2.5 seconds. First input delay, 100 milliseconds. So it's a metric. You gather the metric, and it will tell you if you are within that threshold, so within the budget or not. And CLS, content layout shift, that's a value that you don't understand the value by itself, but if it's 0.1, it means you are good. So you are not shifting content while the page loads. So we will start with these budgets, and then when you know what you're doing, when you know better your goals, you can create your own goals. Okay, but these are the goals that the community is trying to follow today. Okay, so Chrome has something known as Chrome UX that will actually tell you, based on a URL. They don't have the whole internet, but they have a lot of websites. You can try your website and see if it's there. It's a UX report, so that will give you all the information for your website. Let's see this in action. So if you search for Chrome UX report, here we are. You have all the explanation about how it works, okay? And there is an API that you can query about this. And there are some tools available that will let you search that database. This is like a big data where you can play with information about page load, information about metrics for the whole internet. So you can research on, I don't know, it can be travel websites, airlines, how airlines are doing with page load. Okay, so you can research using BigQuery, for example, over this. And there are some tools that will let you see this in action. For example, one is Page Speed Insights. PageSpeed Insights. The URL is pagespeed.web.dev. We'll let you type a URL. Oh no, this is my personal website. Analyze that. It will create an analysis, okay, of that URL, but it's not making a lab analysis. It's what your real users are experiencing on Chrome. So this is data from Chrome users browsing that website. Okay, so I'm passing Core Web Vitals, fortunately, and this is giving me, for example, the largest contentful paint is 1.7 for my website, so it's under 2.5. Then CLS is under 0.1, so it's pretty good. Time to first byte is actually pretty good as well. First contentful paint, interaction to next paint, we don't have data yet. These are like this is the experimental one, and that's on mobile. I can also see the same on desktop. And you can see that most of the metrics are always better on desktop. Unless you have a completely different website, like you have a mobile website and a desktop website. If it's the same website, typically you will get better results on desktop. And that's because, again, we have cellular networks, different CPUs. And also we have this, I have some improvement in accessibility, it seems like. They're changing this. This is Lighthouse. Have you ever tried Lighthouse? No? Okay. So Lighthouse is a tool that was created by the Google Chrome team. Originally it was a plugin, and then it was a CLI, so something from the terminal. Now it's both. It's an open source tool created by the Chrome team. The idea was to create a lighthouse. The lighthouse will point us into the right direction about performance. That was the original idea. So actually it was originally for PWAs, for progressive web apps, to give us in the right direction. But now it's also for performance. So it's a tool that you have, for example, if I load my website, I can also load Frontend Masters. If you go inspect, if you open DevTools on Chrome, you have a whole category, a tab with the name Lighthouse. That's Lighthouse, okay? That's Lighthouse integrated in Google Chrome. But Lighthouse is also integrated with a lot of other performance tools, such as PageSpeed Insights. That is just a cloud-based analysis tool, okay? Where you can create here a report. In this case, it's going to create a report, a performance report, and we will see that in action today on different modes. I will explain these modes in a minute, but navigation is the default mode that will analyze the page load. It will refresh the page, and it will give me an answer in terms of how good or bad I am. And you can see that right now it's giving me 82, not 90 something that was here. Here was 98. Because it's using my computer, my network, my plugins. It's a lab. So maybe I do another one, it give me another result, okay? So that's why this is a lab analysis, and PageSpeed Insights is taking data from that Chrome UX report, from that Chrome UX big database, that is not my computer today. It's real users browsing that website. Okay, that's the difference. Well, anyway, these numbers are coming from this tool, Lighthouse, that some developers are using as a metric. So it's common to see on Twitter, hey, my website is 99 on Lighthouse. So they're using that number, that performance number, as a metric. Okay, that can lead to some problems. For example, one problem, that's not a metric actually, it's a score that the tool is giving us. That is, I mean, it's leading us into the right direction, which is okay, but you shouldn't take that as the most important metric for you, because if not, you're optimizing for the metric and not for the user. Okay, you're optimizing for the score. Yeah.
On that note, Raghav in chat was saying he's been to some websites and web apps that don't have a good score, but they feel fast. When
Exactly, that's the point. So the score, it can give you a bad score, and anyway, because it's an automatic tool that is giving you a score based on a list of options, and each option has a different weight over the score. And you can create your own score, actually. The problem with the score is that there are a lot of developers just optimizing for the score. And they're not understanding web performance. They'll say, oh, I have 99 there, I'm good, and maybe you're bad. Or the other way around, as someone was saying in the chat. Maybe you have a bad score, but you feel it's pretty fast. So maybe the score is not so important. So have that score there. It's okay to get it, but it's better to understand the vitals behind that and understand what's going on. Okay, so have that in mind. So, but PageSpeed Insights, again, pagespeed.web.dev is a free tool that will give you the Chrome UX report data. That again is not just a lab test. It's actually testing with real users on real networks, which is actually pretty good to get like a better idea of what's going on. Okay, for example, this is my speed index. Again, speed index 0.8 seconds. Is it good or bad? Well, it's green, right? So we know it's good, but I don't know what that means. In terms of, remember, the speed index is the area above the curve. So yeah, it's 0.8, and this is good or bad. But actually, if it's below 2.5 seconds, typically it's good. So that's the amount of blank that the user has seen over the page load process. Okay, and here there are a couple of opportunities to improve, that we will see this later. Okay. Anyway, remember, you have mobile, you have desktop, and you can see that on mobile you will find more users under the red. This is the percentage of users that were over the red. You can see it's typically higher on mobile. Why? Cellular networks. That's the latency. On desktop, you don't have such, I mean, you might still have latency problems on desktop, on your Wi-Fi if you have a problem, but it's not so common. You will probably see that there. And you can try here any website.
Yeah, my personal project, the mobile performance is 60, and then the desktop is 94.
Well, why? There might be several reasons. We will understand later how to analyze that data and how you can improve that.
That's a big difference.
Yeah. And if it's a real user metric, it's using the real latency for your real user. So there is no thing here like, no, maybe, no, this is what your users are actually experiencing. Okay, so that's actually, fortunately, this is free, PageSpeed Insights, because if you want to use directly the Chrome UX data, you want to query that, it's open, but you need to pay for the queries. So it's big queries, you have like a free budget, but then you have to pay for that in case you want to create, you want to make queries even if it's on your own website. And today, some of that information, not all of the information, but some of that information also appears under Google Webmasters. That's the place where you, as the content owner of a website, you can see information about how Google sees your website for SEO. Well, and now you have a performance section there as well. But as a summary, on PageSpeed Insights, you can see Chrome UX reports on your own URLs. If it's a new URL or if it's not indexed in Google, you won't see that, and you will need to get lab data in the meantime. Okay, let's go back here. Already seen that. So now we've seen the metrics. So we know the metrics that we need to improve and the bad sheds that we have. Okay? Now let's talk a little bit about tools and charts. Most of the time we're going to work with, so our most important tool for web performance will be that chart. That chart is a waterfall chart. That chart will show you in y-axis from top to down resources in the order that they were downloaded, and the x-axis time. From 0, that's from the navigation start, to typically page load. It can also be over page load in case you have a client-side application. So each row is a different resource. What's a resource? A file. An HTML file, a CSS file. It can also be a WebSocket request. It's a request. Okay. we will use these charts a lot. These charts typically they have on each bar, you will see a bar, different colors. Unfortunately, we don't have a standard for colors. So each tool will give you a different color for the same thing. Each bar, so for example here we see green, then orange, then violet, then another light green, and then blue, are showing me in the time different parts of the loading process. Okay, we'll get into the details on that. For example, I'm requesting a page. The first step is the request. So I'm waiting for the server to respond. Then the server responds, and then I'm downloading the file. Make sense? I'm downloading the bytes over the bandwidth. And when I have the file, I need to parse the file. Well, each step will be a different color in the bar. So you can recognize what's going on. And typically, waterfall charts, they look like this. They are much more complex than the simple one that you saw there. And we have two per URL. One for the first view and another one for repeat view. Because if it's the first time you're accessing that website, you have never seen that website before on that browser, that's first view. You have a completely clear cache. Your computer doesn't know the IP address of the server. And then we have repeat view. In that case, you're coming back. It can be 1 minute later, a week later, and the repeat view might take advantage of some things, such as caching. Okay, make sense? So different tools, as I mentioned, will give you the same information differently. And also you will find sometimes that there are some vertical bars or lines. Can you see those here? Here. Those are milestones over the timeline. Typically, the milestone from the metrics that we saw, such as time to first byte, first paint, largest contentful paint. So you will see those vertical bars happening there. So then you understand what's going on. Okay, makes sense? We will see this in action now with our project anyway. Another tool that is actually pretty good to see is called the film strip view. In this case, the film strip view is a list of screenshots that you can see in an array. It's an array of screenshots taken over time. This is actually pretty good to actually feel the pain of your websites, and actually how you can convince your managers that your website is slow. Because I'm pretty sure that some of you might go to your manager and say, hey, our website is slow. It's taking 12 seconds to load. And for your manager, 12 seconds is actually pretty good, pretty fast. Oh, 12 seconds, it's nothing. Okay? Well, the way to prove that that's a lot is to show the film strip view. Okay? So I'm going to get out of here, and let's try to see the tools that we have to see this in action. Well, first, if I'm in Chrome, let me start closing some tabs that I'm not using. We can go to frontendmasters.com. I can open DevTools, and now we can go to Lighthouse, that's okay, but also there is a performance tab there as well. In the performance tab, you can start recording something. You can record a session. You can enable Web Vitals, so you can actually see those metrics, the Web Vitals metrics, the most important metrics there. You can throttle the CPU. What is that? It will try to throttle to slow down your CPU to simulate a worse device. I have an M1 Max here. Yeah, maybe that's not the CPU that everyone has. So you can try to slow it down. And I can also throttle the network. I can simulate the FAT3G, or I can add here a custom profile. I can say fast 5G. You set the download, the upload, and the latency. And it will simulate that latency as well. Does it make sense? So you can throttle the network. This is not a real user metric, but you can simulate one. Okay, makes sense? So, and then you hit record, and then you can refresh the page. It was pretty fast anyway. So then when you say stop, and here you will see what the timeline and what was happening. The performance tab that we have here is not just for network requests. It will show you everything. It will show you also, for example, rendering process. So what was going on in the CPU. So you can go over here and see how, can you see that thing? That's a layer shift. If it's bad or not, it depends on the CLS value that you get. Maybe it's not really bad. It's pretty good. So this is one tool. There are many tools available actually. Another tool that we have is another tab, the network tab. This network tab is available on Firefox and Safari as well. I'm using Chrome because it's the browser with more tools for web performance. Compared with Safari and Firefox, it's far beyond the other browsers in terms of tools available. So if I refresh the page, what you see here, it's actually the waterfall chart. You are seeing it differently, but it's a waterfall chart anyway. And let me open this in a new window. Maybe I'm going to decrease the font size a little bit to see the better. Where is it? Oops, here. Let me refresh. There we are. Let me change a little bit. You can see you can reorder the network tab. I need to make the waterfall column larger. So what you see here, let me refresh again, is the waterfall chart. By the way, if the website is still making requests, as it is, it's changing it on the fly. So maybe what you want is refresh, and then pause here the recording. So now it's not going to change. It's a static analysis tool. So this is a waterfall chart. You can see each request over time. Okay, over time. And each bar has different colors. We have a green, we have a blue. Maybe you don't have that priority column that I'm seeing here, so I'm going to disable that. We're going back into it later. By the way, you can see I can right-click over the columns and add or remove columns. And there are a lot of information you can get from here. And remember, I'm in the network tab in Chrome DevTools. Okay? So this is a waterfall chart, and here you can see there is a blue line here and a red line here, the vertical line, that does express at which moment something has happened. Also, something that you can do from here is click Capture Screenshots. If you click Capture a Screenshot and then reload, now we are going to see what happened on the website at that particular moment in time. And by the way, Frontend Masters is pretty fast. So that's why we're not going to use it as an example of something that we can improve. There's always room for improvement on every website, but it's better to try to find one sample that is not already optimized. But I'm just showing you how you can use DevTools to see the waterfall chart that we will see during the rest of the day, and how to see film strip view. Okay, so Chrome DevTools is the first tool that we typically use as performance engineers. In the network tab, the performance tab, and also the Lighthouse tab. I'm not sure if you know this, but you can drag the tabs as well there. So you can put them all together as a group of performance-related tabs around Google Chrome. What other tool we use? I'm talking about free tools. Web Page Test. Web Page Test is a website. It's the Bible of performance engineers. Now it's owned by Catchpoint, but it's still free, the tool. It's open source, by the way. In WebPageTest, you can enter a website URL, per.dev, pick a simple configuration, or you can select a lot of advanced parts. So you can, for example, select to run a Lighthouse audit or include a repeat view. So it will actually make the analysis, then refresh and make another analysis with the cache inside. By the way, it's changing the color, right? The background color. We can start a site performance test. That's what I want. Only see Core Web Vitals. Visual comparison will let you have 2 versions of your website in case you have, I don't know, the staging and development. You can put 2 URLs and see the comparison. But let's start with just default site performance. And here you can say I want mobile, I want desktop, and this is going to use real devices on a lab. And because it's a real device, it's a limited resource. Sometimes you need to wait, okay, for that resource to be free. It will take some time, and then it will give me the answer. This is one of the most complete tools for free that we have for web performance. So it's a must tool. So we have a summary. We have the performance metrics. By the way, this is not a real Chrome user metric. This is right now. So right now, with one device in one particular part of the world, this is what we got. The other one that we saw is the 75% of our users. So for some reason, right now, I'm over 2.5 on largest contentful pane. It can be the server, the CDN. Something is taking more time. And here we can see the visual page loading process. If you click Explore, remember I mentioned that this is how you can fill the pane. So this is the film strip view. Okay. The film strip view, I can change the settings, and I can say I want to see one screen every 100 milliseconds. So now this is what you see. Can you see why, and then something. So remember I said this is how you can fill the pane, or you can show your managers that this is a flow over a timeline. And you can also view a video. And if you want a slow motion, the video, but I don't think you need that, okay? But with the video, you can fill the pane. Yeah, my website is not so slow, but you can still feel the pain, the whites. So that's what you show to your managers to show you that 12 seconds is too much. They can feel the pain in the video with the timer at the bottom. Okay, makes sense? Let's go back. That's the video of the loading process. One important part that we have here, this is pretty cool. Can you see that red line we have there? There is a red line here. That red line continues here. So what I need, for example, let's say I want to know what happened in the timeline when we see something like here. It seems like here there was something that happened that went from white to almost seeing the whole content at once. So what I'm going to do is I'm going to move the scroll, so I'm going to match that red line with this part. So I will do this there, okay? Now that red line, I mentioned it continues here. So now I can scroll down and try to understand what happened in the waterfall chart that my content appeared at that point. So at this point, I can guess only that all these CSS files were downloading. You can see a font from Google APIs, and I think that that's the only thing that I can get from here. So remember I mentioned that CSS should be an appetizer? Remember that? Short and, well, that's because the browser will not render a pixel before having all the CSS file downloaded and parsed. And we can see that in action here. We didn't see anything on the screen before the CSS files were downloaded. Does it make sense? So getting a master of this tool will give you will convert you into a master of web performance. Yeah.
Excuse me. What is the name for that line that you were pointing
No,
at?
this
Is
is,
there a name?
no, there is no name. It's something from the tool, so it's a guide. It's a guideline for the tool.
Yeah.
So but it's just for this tool for web page tests. I don't know if it has a name.
It's not like a metric of some sort.
Yeah,
that
it's not a metric. No, it's part of the tool that will let you scroll your film strip view and match that with the timeline. By the way, here can you see there are some green lines? Those are largest contentful paint or first paint. Those are the other metrics that we were mentioning. And what is this? Can you recognize this chart? We see here this graph. This is the graph that makes speed index. So the speed index was the area above the curve. That in my case it was 0.8, I think, which is good because it's less than 2.5. Maybe you're saying, well, but that's not really, doesn't feel good. Well, if your final value is still within 2 seconds, 5 seconds, it doesn't matter because remember we are measuring how much blank the user has seen over time. We have another question, I think. No? Okay, it was just me. And well, more information will appear here for web page test. So it's actually a great tool, and we will use this tool a lot for web performance analysis. The disadvantage of this tool is in the cloud, so your content should be public and accessible. It doesn't work local, with local content. Unless you download web page test and run it locally, that you can, because it's an open source tool. So you can create your own local infrastructure for running your own web page test solutions. I'm talking about companies that they don't want to public their content, or they don't want to use a service that is from another company, in this case Catchpoint. So well, that's okay. You can download and create your own instance of web page test locally. Does it make sense? So as advanced web performance engineers, we are not going to just rely on the score from Lighthouse. We are going to use tools such as web page test to analyze the whole situation and try to find moments for improvement, things that we can improve. Do you have any questions? No? Do you remember that I mentioned that web performance is a front-end thing, not typically a back-end thing? Well, now that we know what a waterfall chart is and how it looks like, we can actually prove that. So if you look at that chart, that's a simple waterfall chart. And I ask you, by the way, it can be more complex as well, not just so simple. And if I ask you, where is the backend time there? How can you respond to that? Where is the backend time? Yeah.
Would it be that period of time from when the HTML request started to it ends?
So it's first, you mentioned the HTML. So the HTML in here is that one only, right? So it started and end. So yeah, that's correct. In fact, it's even less than that, and I will show you why. So the backend time here, so I don't know why that thing appears there. Anyway, let's see here in this one. So the backend time is just that 5%, even less than that. All the rest, and how the browser is loading resources, they might be also contacting the backend, but it's not your Node.js, your Next.js code, your PHP code if you want. That code is just that small portion. Okay, and our metrics, the metrics that matters, such as first contentful paint, typically they are around here. So we have a problem. The server It's just that part that you see there. Not even the blue part, because the blue part in this chart, I mean, I'm talking about the blue, where is it here? That blue bar, that's downloading the file. That will change based on the bandwidth. The server responsibility is just that part. All the rest has to do with how we define things in our HTML. So it's front-end responsibility. Make sense? And from the top 100,000 sites, only 84%, or only, let's say, 16% of the time is because of the backend. Okay? Optimizing the backend has less impact, and it's not a simple or cheap task. I mean, you want to optimize your server time, you want to cut 10% of the time. Sometimes it's about buying some or putting some more infrastructure or cloud infrastructure, pay for some, I don't know, cache, or adding another layer of something, right? It's expensive, and if you think about that, if you can cut 10% of the backend time, how much impact do you have in first content load? Remember, go back here. How much impact you will have if you just change this by 10%? It's not going to change a lot. Yeah, everything will move a little bit that way, but just a little. But optimizing the front end has high impact. You make a change in HTML, and automatically you can see higher impact on every metric. And it's cheap. It's just changing the HTML. Not on everything that we will see, but it's typically cheap. You have a question on the chat?
Yeah, just a comment that there is no API calls here, but sometimes when you are doing web apps, then you have to make a lot of API calls, and those API calls.
Those API calls, yeah.
Could be slow.
Yeah, sure. But that, I mean, that's the case. In fact, it will be the case in the project that I have that we will test after lunch. And for now, we are focusing on the first load. If your first load, the first page load, needs content from APIs to render the initial page, you might have a problem. But yeah, that's true. That's why I said it's not like the backend is dead after the first initial HTML, but typically it's not the biggest problem. If you need to call APIs to render your landing page, you have a different problem. And again, I'm looking at you, I'm watching at you, React developers. Okay, so that's a problem. That's a problem for performance. And maybe you say, and there are always excuses. No, because my team is blah, blah, it's better to do this in this way. The answer, in my experience doing consulting for big companies or large companies, the answer is actually, you know what? The CEO realized, someone told the CEO that they're losing money because of web performance. So then the order goes back to the CTO. We need to do web performance no matter what. No, but infrastructure said that it's better to do client-side, blah, blah, blah. No, it doesn't matter because we're losing money. It's about money, okay? At one point, you need to go over this. And sometimes it's a lot of money. I had one example, it doesn't matter exactly which customer, but they were doing bets online. It was directly about money, like online poker. And they were pretty bad at performance until the CEO was playing golf with another CEO from another company, and they said, hey, you know that if your website loads within 4 seconds, you can improve. And after that, they shift the whole company with like 500 employees. Our focus is to get into those 4 seconds, no matter what. Before that, yeah, developers were trying to push web performance, but at the end it was no, but infrastructure doesn't want that. So the company was not aligned with the idea of web performance. They didn't understand why. Oh, those geeky nerds from the front-end team, they wanted performance. It's not important. Well, it is important for the business, and we are doing that it's not for the sake of performance. We are not doing web performance for the sake of performance. Okay, we're doing this because it's improving our business. If we remember that goal, maybe it will work better. Okay, make sense? How's lunch? Is it lunch ready?
Yeah, lunch is here.
Okay, so let's do lunch then, and after that we'll start understanding the browser, and then starting talking about, okay, how can we optimize this? Okay, 50 minutes or 40, 1
Yeah.
hour? What do you?
Yeah, I mean, are you feeling behind
No, we're good.
or good?
We're good.
So 50 minutes is probably fine.
50.